Thank you, Roberto, for the introduction, and thank you for inviting us for this very interesting summer school. Yes, at the moment I am working for the Aquabiotech group in the last 7 years already. Aquabiotech is an SME based in Malta, in the Middle Mediterranean, and our main activity is to design and build recirculating aquaculture systems. And we also have our own recirculating systems here, where we do contracted research for the big aquaculture companies. And our third main activity is to do aquaculture, fisheries, and environmental consultancy. At this time, I will talk about the iFishIENCI projects, which is a collaborative work of many different partners. I will have a slide about the partners as well. So what I am presenting today is the work of many different partners, SMEs, and research groups. iFishIENCI is also a Horizon 2020 project, like the previously introduced Impact, but this project was granted within a different call. The short name of this call was the Aquaculture 4.0, which a little bit summarized the main aim of the call, that to integrate the latest results, the latest new technologies for other industries as well in the aquaculture, and create new developments, new technologies for the aquaculture. These projects, 4 projects, was selected for this call, including the next presentation about the new tech aqua, which is also funded under this call. So all these projects are innovation actions, where it is expected that the projects has to provide new products by the end of the project. So in my presentation, I will talk and I will focus on I will try to step with the slide, but do you see my slides? Because I just see the first slide and I can step. Okay, it's stepping now. So all project has to provide new products for the market, for the aquaculture, and all the 4 projects funded under this call has different focus with some overlaps. In case of the iFishIENCI project, we try to answer the challenges, the main challenges of the aquaculture industry, and we identified these 4 main challenges: the environmental limitations, the feed sustainability, the disease and parasites problems, and the impacts of the climate change on the aquaculture. So in the project, we designed the products and research and innovation activities which can help the fish producers and aquaculture producers to deal with these challenges. But in the focus of the project is the feed and feeding technology. How can we better use the feeds which are available on the market already, and how can we further develop these feeds by using the new digital technologies? So this is the other focus of the project, to integrate the new digital technologies in the aquaculture, a little bit similar like the Impact has done in the field of the IMT systems. So the approach of the iFishIENCI project is to develop a platform for testing these new technologies. Because it's an innovation action, we try to use technologies which are already close to the market or already on the market, and just adapt these technologies for the aquaculture to create new products. And we test these relatively new solutions in a controlled environment. This is why recirculating aquaculture systems are very important in this project. And then using these results, we can bring these solutions to the production system and production fields, and support the business development and the market growth of the partner companies. this is the design sheet of the project. So as I mentioned, the focus of the project is to develop the aquaculture technologies for the better use of the feed. Feed is the main cost element of all aquaculture production. In intensive aquaculture production, it can be more than 70% of the total production cost, the feed cost. And as you know, at the moment, the feeding and feeding technology is mainly depends on the experience and knowledge of the people who are feeding the fish. Even in the highly digitalized salmon industry, it still depends a lot on the people who operates the feeding systems. So the idea was that to support the feeding technology with new Internet of Things solutions and artificial intelligence based control system, which can investigate the feeding behavior of the fish and support the decision when to feed or when not to feed the fish. And we also developed in the project some new feed elements, feed stuff, which we test. We focused on the algae based products, but also yeast was tested. And in the early stage of the project, we tested a fungi product, but it was not very successful, so we rejected these feed ingredients. And all these information, of course, and all these technologies are also very important for the sustainability perspective, because feed also can the feed is also an important part in the environmental impact of the aquaculture. Overfeeding can cause result serious pollution, or it can be a problem even in the closed recirculating aquaculture system, because then the system needs more energy to treat the water. So these technologies will be further developed, and the project planned 4 main products, which I will introduce you in more detail later. So this is the geographical distribution of the partners. We have 16 partners in the project, which is a mix of SMEs. There is a very high representation of SMEs in the project. As I mentioned, is an innovation action. So the aim of the SME is to exploit the results of this project and develop new products. But we also have research and academic partners in the project to support the research and innovation activities. And the Aquabiotech group or organization is the coordinating organization of the project. The project is still running. The planned duration was 4 years, from November 2018 until 2022. But we have some delays because of the COVID situation. But we are still trying to catch up with our task. This is the list of different type of organizations. The project has a kind of focus on the most important species. One of our focus species is the salmon, of course, the Atlantic salmon and the Nordic aquaculture. But we have a strong focus on the freshwater aquaculture as well. Rainbow trout is one of the model species of the project, where we test the new technologies on this species, especially in recirculating aquaculture systems. And we also have some other interesting species in the project, like, for example, the African catfish. which we think is an emerging species for the world aquaculture, not necessarily for the European aquaculture, but also important in Europe. But for the world aquaculture is important fishes, and similarly, the tilapia also was included in the list of the species which are investigated in the project, because this species is very important for the world aquaculture. And of course, the project, the Mediterranean partners in the projects are working with sea bass and sea bream, both in cages and also in recirculating aquaculture systems. So let's see now the main products of the project, the main planned products. Of course, these products are still under development, and the information what I can provide for you at this stage about these products are a little bit limited because of the intellectual property rights issues of the projects. But I try to give you an overview of each products what we plan. And if you are interested, please contact the project, and we can start the discussion about your questions. So the first and one of the core product of the project, the so-called iBoss system, which is the iFishIENCI management support system. The core idea of this product is that we wanted to create a system, a cloud system, which is compatible with different farm management systems. As you probably know, there are many farm management systems already on the market. These are usually quite specific to the sensors what the farms have. And in the iBoss cloud, in the iBoss farm management system, we want to create something which can work together with different farm management softwares, or can work alone as a farm management software on a farm, and can integrate data from the production side, but also from other sources. For example, meteorological data from open databases, or satellite data from open resources. It depends on the choice of the farmer, of the producer, what type of data they want to integrate in this iBoss system. In the project, we are focusing on the data production from the sensors. From sensors which are already developed by our partners, especially by the Oxyguard and Biosenor, who are our main sensor developing partners. And they work closely together with the Easy Global Market, who is developing the iBoss cloud. And the idea is that iBoss will integrate some smart solutions in the cloud system, where the data gained from the sensors and from the systems can be analyzed and provide the information for the farmer. The second product, which is a little bit a part of the iBoss product, is the Fish Talk to Me product. Basically, the Fish Talk to Me is the data collection, the data producing part of the iBoss system. In the iFishIENCI project, we are focusing on environmental data, which are collected through the sensors of the farm. When we are talking about farms, we are talking about cage farms in Norway and in the Mediterranean, but also recirculating systems like here in the Aquabiotech and in other partners. But we also use sensors in other systems, like in a flow-through system of an African catfish farm. And we also tested the sensors of a partner in Laos in a tilapia experiment. We also have a strong focus on using camera and imaging data to evaluate the behavior of the fish. These experiments are mostly running now here in the aquabiotech, but we also use this technology in cages. We also use fish tags, biomarker tags, which are already in the market, and test how can we better use this to provide data for the IBOS system. And we are developing now the control mechanism. How can these data control the feeding robots of the different farms? The product which is the closest for us in the aquabiotech is the SmartRAS product. You have to know that recirculating aquaculture is a widely used technology now everywhere, almost everywhere in the aquaculture. It is very well established technology in the salmon industry to produce salmon smolt in freshwater, but it is more and more used also in the Mediterranean aquaculture, where the stocking material for the cages are mostly produced now in intensive systems, and recirculating aquaculture has a growing role in this. The producers are, the Mediterranean producers are trying to produce the fish up to 10, 20 gram in this intensive system and just stock at this size in the cages. But recirculating systems also has a very high investment interest, because the salmon production has a growing market, but the environmental limitations of the production site does not allow to grow as fast as the market grows. So many investors are considering now to produce Atlantic salmon in closed recirculating systems up to the market size. And there are many other species where market size fish are produced close to the market and sold to the market. Because it's a very intensive technology, most of the recirculating systems are very well equipped with monitoring systems. But these monitoring systems are used mainly to remind the farmers and notice the farmers if something is wrong with the farm, something is wrong with the water quality, especially, or something is wrong with the equipment of the farm. And however, we collect a lot of data on this in these recirculating systems. We don't use this data as a kind of precision aquaculture system, and don't use this data to learn more about the system and control the system. And this is what we want to develop in the SmartRAS concept in the iFishIENCI project. We have three main areas of the innovation here. That we have innovative new water treatment technologies in the design of the recirculating systems. We are developing now a new feeding technology based on the fish behavior, and where the feeding robots are controlled by the fish behavior. And the third main innovation is to collect all this data in the IBOS edge and in the IBOS cloud, and use predictive algorithms to calculate expected water quality data, for example. And all this innovation we expect will support also the improved use of the discharge of the recirculating system, which is connected a little bit to the fourth products of the project, which is the waste to value product. As many other speakers before mentioned, to use the waste streams, the various waste streams of the aquaculture production in the aquaculture or in other industries has a growing interest and a very interesting issue in our industry. In the efficiency project, we are focusing on the reuse of the nutrients and water from the intensive systems, but in this waste to value products, we would like to create a kind of decision support system, an internet-based decision support system, which also can integrate the results from other projects. So when we reach the point that we will see more clearly the structure of this product, we will contact all the other projects who worked on this field, and we'll discuss how this platform could integrate their public results and their data to support the farmers to make a decision how can they reuse their waste from the project. In the efficiency, one of our main focus is to see what can we do with the effluents from the recirculating aquaculture system. Probably you know that all recirculating systems, however, it's recirculating the water and treating the water continuously, but still has 5, 10, 15% of effluents of the total water volume, which is usually very concentrated effluent, high in organic materials, high in nutrients. It can be a very valuable resource for other industries as a fertilizer product, or also for other type of aquaculture production. It's a little bit different than the IMTA system, because as Frank said, in the IMTA systems, it's very important that all the elements of the system are integrated. They are on the same place. In our case, we also want to investigate how can we use this waste products on other locations. So how can we separate, for example, and how can we extract the nutrients from the effluents of a RAS system on the site, and then use this product somewhere else. And this is what this new tool plan to support and facilitate such kind of activities. And there is a kind of horizontal product of the project, and this is the breeding element, and this is where African catfish is the main species. In this breeding experiment, we also try to integrate all the solutions, all the sensors, environmental parameter investigations, new feed products, what we developed in the project. The core idea of this project, that we have several feed ingredients already, which are made from waste product. The most well-known and already used product is the use of processed animal protein in the aquaculture. And they use this protein as a source of valuable amino acids instead of using fish meal. It's a more environmental friendly and more sustainable way of feeding. But sometimes fish has not as good growth rate on this type of feeds as on the high quality aquaculture feeds. And the idea was that we can select a line of African catfish which can grow better on this type of low fish meal feeds, and we develop a breeding program for this, which breeding program also can be used and can be repeated in other countries. The preliminary results of the experiments are quite promising. The new generations, the latest, we are at the moment in the F3 generation of the fish, and we could detect a quite good growth rate compared to the control groups. And in the next steps, we still have to test whether this new line can provide this higher growth rate in a different environment. So we will test the African catfish in a recirculating aquaculture system as well. At the moment, they are produced in a flow-through system, as it can be seen on the pictures on a farm. So the aim of the project is to create to bring to the market all these new products by the partners, and also test these products in an operational environment. And these are the tasks of the next year. And at the moment, we plan to finish it in time, but probably we will need some extension because of the COVID delays. And as I said, just to develop a better feeding technology which can reduce the wasted feed can gain a lot of value for the producers. I don't want to go into the details because I think we have some delays. But our focus now is on the bringing all these innovations to the market. So thank you for your attention in the name of the whole iFishIENCI consortium, and I think I will answer the questions in the chat because my time is probably over. Thank you very much for your attention.